Ever pondered what makes deep networks so phenomenal at solving complex problems? Deep networks, the bedrock of modern machine learning, have an uncanny ability to mimic one of the universe's most intricate creations, the human brain. These networks, a form of artificial neural networks, are designed to replicate the way our brains process information. At their core, deep networks are all about pattern recognition. They digest vast amounts of data, analyze patterns, and make predictions or decisions based on those patterns. From recognizing faces in a crowd to predicting stock market trends, deep networks have proven their prowess time and again. Yet despite their remarkable abilities, deep networks are not infallible. Like any other technology, they can be improved, refined, and perfected. The potential for enhancement is limitless, just like the human intellect they strive to emulate. The question then becomes, how can we enhance these intricate deep networks? Improving deep networks isn't as daunting as it may seem. It involves a series of systematic steps. Let's embark on this journey, shall we? First up, we have data collection. The quality and diversity of your data can make or break your network. You see, a network is only as good as the data it learns from. Imagine trying to learn a new language but only having access to a single outdated textbook. You might learn something, sure, but you'd miss out on so much more. That's why it's essential to collect high-quality, diverse data. The more varied and comprehensive your data, the better your network will perform. Next, we move on to designing the network architecture. This is like designing a blueprint for a house. You need to decide how many layers your network will have, what type of layers these will be, and how they'll connect. Will you have a simple feed-forward network, or perhaps a complex convolutional neural network? These choices will largely depend on the problem you're trying to solve and the data you're working with. Our third step is training the network. This involves careful initialization and optimization. Initialization is like setting the starting point for a race. You want to give your network a good start, but not too good that it skips crucial learning. Similarly, optimization is like choosing the best route to reach the finish line. It's about finding the best set of weights that minimizes the error in your network's predictions. Lastly, we have regularization, which is our safeguard against overfitting. Overfitting is like memorizing answers for a test instead of understanding the concepts. Sure, you might ace that specific test, but if the questions change even slightly, you're out of luck. Regularization helps the network generalize better, ensuring it performs well not just on the training data, but also on unseen data. Each step in the process is crucial and plays a significant role in improving the performance of deep networks. So remember, when it comes to deep learning, there's no shortcut to success. It's a systematic journey of learning, tweaking, and improving. So, what are the vital points to remember when seeking to enhance deep networks? Let's start with a recap of the 4 main steps: data collection, network design, training, and regularization. Each of these steps plays a crucial role in shaping the performance of your deep network. First up, data collection. It's not just about quantity, but also quality. The data you feed your network will determine its ability to identify patterns and make accurate predictions. So ensure you have a diverse and representative dataset to fuel your network. Next, we move on to network design. Here, the goal is not to create the most complex network, but the most effective one. Think of it as an architect designing a building. The best designs strike a balance between complexity and functionality, ensuring the network can handle the task at hand without becoming unnecessarily convoluted. The third step is training. This is where your network learns to make sense of the data it's being fed. Proper training involves carefully setting the learning rate, deciding on the number of epochs, and choosing the right optimization algorithm. It's like teaching a child to ride a bike. You need to provide the right amount of support and guidance without doing all the work for them. Finally, we have regularization. This is all about preventing overfitting, ensuring that your network can generalize well to unseen data. It's like putting the finishing touches on a piece of art. Regularization techniques help to fine-tune your network, striking a balance between underfitting and overfitting. But remember, while these steps provide a solid foundation, they are just the beginning. The field of deep learning is dynamic, and there's always more to learn. Innovations are happening all the time, new techniques are being developed, and fresh challenges are constantly arising. Improving deep networks is a journey, not a destination. The field is constantly evolving, offering exciting opportunities for those who dare to dive in.